Welcome everybody. Today we're going to be looking at 9.4 parent functions. So parent function is the simplest function of the family. So we're going to be looking at a few of them this unit. So with each parent function, it's got a name. So the first one we're looking at is a linear function. So you guys have been looking at linear functions for a lot of your math career. That's like y equals mx plus b. So the parent function for it is y equals x. So that is just the simplest form of it. Y equals x is a line that starts at 0 and then has a slope of 1 over 1. So it's cutting through the origin, and it is that line with a slope of 1 over 1. Features of the equation, you'll notice, is it's going to have an x, and its biggest exponent is going to be an invisible 1. So kind of think about it, it doesn't really have an exponent, but it really is an invisible 1. So its biggest exponent is the invisible 1. So usually it's like an x, but it's got like an x to the 1. Features of the graph, I'm sure you know it is a straight line. That's what makes it linear. Up next, we've got quadratics. So you've also seen those multiple times in your math career. That is when you have a y equals x squared. So you know it's a quadratic if the biggest exponent is a 2. The parent function graph is going to have a point at the origin, and then it's a u facing upwards. And that u can be transformed to go like down or up, but it originally faces up, and that's its parent function. So features of the graph, it has a U shape. Cubic is another one you guys have probably heard of. That is when you have y equals x cubed. So I know it's cubic because the biggest exponent is a 3. I don't think you've seen these graphs very often, but they also touch the origin. And they have opposite end behavior because they are odd. So they look like this. So that is the original. So that is positive and odd. So the right side goes up, the left side goes down. Things you can look for, it's going to be curved. It's going to have that little like curve in the middle. And they always have opposite end behaviors. Another graph that you haven't really seen very often probably is a rational. So a rational is when the x is on the bottom of the fraction. So the parent function for that is 1 over x. And I know something is irrational if the x is on the bottom of the fraction. And the original parent function for a rational has these two little loops in the corners. So they are opposite each other. And one's in the upper right, the other's in the lower left. Something about rationals is they have these things called asymptotes. So there is a asymptote or a line, an invisible line that these curves get really close to but never touch on the y-axis and on the x-axis. So those curves get really close to both axes but never actually touch them. So that's called an asymptote. Features of the graph. So there are two separate curves that are across from each other. Next we have a radical. So we know that radicals mean square roots. So the parent function is y equals the square root of x, or radical x. So the way I know that something is a radical equation is if it has that square root sign. So if the x is in the square root sign. What the graphs look like is, you know, you can't take the square root of a negative number, but you can't take the square root of 0. So this one starts at 0 and then goes to positive numbers. So it's never going to go to those negatives unless there's some transformations done. So features of the graph, it's going to have a starting point. And then it curves to the right. Unless it's being transformed, and then it might curve a different direction. Finally, on this page, we have an absolute value graph. So you've probably seen absolute values before, but you may not have seen their graphs. They look like absolute value of x. So those bars say an absolute value. So in an equation, I know it's an absolute value because it has those absolute value bars. I'm going to abbreviate absolute with ABS because it just takes a while to write absolute every time. So it has the absolute value bars around the x. So an absolute value, you can plug in any x to it, but it always outputs a positive number. So these are going to start at 0, and then any x you put in, it should be going up because it's going to be going positive. So they create this V. So the features of the graph, it's going to have a V shape. So it looks similar to a quadratic, but a quadratic is more curved, it makes the U, and an absolute value makes the sharp V. All right, we've got two more. We're going to look at this unit. So we've got an exponential function. So an exponential function is any function where the x is the exponent. So because it's any number, we use a b to represent that number to the x power. So b just represents any number. So I know it's an exponential if the x is the exponent. So exponentials, the way they look as a graph, is the graph starts off flat and then it curves up and grows exponentially. Just like those rational functions, there's an asymptote here that's like an invisible line that this is never going to cross. So it's going to get really close to the x-axis, but never actually cross it. So features of the graph, it starts curved, or it starts flat, sorry. Then it curves up exponentially. Finally, the inverse of an exponential is a logarithm. So logarithmic functions are when you have y equals log x, or you might see it as a natural log. So y equals ln of x. So when I write that, I like to do a cursive L. So, oh goodness. So y equals log x or y equals ln x, both of those are logarithmic. And we'll talk about what ln means next unit. So features of this equation, you're going to literally see the word log, so that helps tell me it's logarithmic, or you'll see the ln. And on a graph, this is the opposite of an exponential, so this one's actually going to be flat across the y-axis, and then it's going to curve out that direction. So just like before how it had an asymptote on the x-axis, this one has an asymptote on the y-axis, so it gets really close but never touches the y-axis. So features of the graph, this one starts like straight up and down, so it starts vertical, then it flattens out. Okay, so what we're going to do this unit, now that we know all the functions, is we are going to look at graphs and look at equations and try to name them and write their parent functions. So looking at the graphs, the first up, easy peasy, we've got a straight line. We know those straight lines are called linear functions. And the parent function for that is y equals x. Up next, we've got a u, so it's got that curve in it, so u's are quadratics. And a quadratic is y equals x squared. Number 3, you can see it's got a starting point. So the only one that has like that starting point and goes one direction is the radical, which a radical we know is another name for a square root. Number 4 is the only type that has two separate curves. So two separate curves is a rational, and that is when x is on the bottom of the fraction. Number 5, we've got that little curve in the middle. So the little curve in the middle is a cubic function. So notice these don't look exactly like the graphs we drew. These have all been transformed. So that's why they look a little bit different than what we drew before. So that one is y equals x cubed. 6, we've got another linear, because it's a straight line, so y equals x. Again, it's been transformed, so it's not exactly y equals x, that's just its parent function. 7 is that sharp v, so sharp v is the absolute value. So absolute value are those bars around the x. 8 starts off flat and then curves up sharply, so that is an exponential function. So that's y equals any number to the x power. I would recommend trying the next ones on your own before watching it. So number 9, it's got that little curve in the middle, so that is cubic. And we know cubic is a 3 as an exponent. 7 starts out vertically and then curves, so that is a logarithm. So it is logarithmic. I always have to sound out that word. So if you said y equals log x or ln x, either one of those would be good. 11 is a curve. It's a nice U shape. So U shapes are quadratics. So y equals x squared. And finally, this one starts off flat and then curves up sharply, which is an exponential. So y equals any number to the x. All right, when you are ready, flip the page. Let's look at some equations. So now we're doing the same thing, except now we're looking at an equation instead of looking at a graph. So the first one, instead of y equals, they say f of x equals, means the same thing, just function notation. So I'm looking at this side of the equation. So I see an x, it doesn't have an exponent, so its exponent is that invisible 1. So that tells me it is linear. So its parent function is y equals x. And it's been transformed with that 6 and minus 3. Number 2, ooh, I see a squared. So squared immediately tells me quadratic, because its parent function is y equals x squared. 3, I see the x is inside of a square root, so square roots are called radicals. So we've got y equals square root of x as its parent. Number 4, x is on the bottom of a fraction. So when x is on the bottom, that's a rational. And its parent function is 1 over x. 5, the biggest exponent is a 3, and x is being raised to it, so that is a cubic. So its parent function is y equals x cubed. 6, I see a 3 outside of the parentheses, but the x, when I think about what's being done to it, its biggest exponent is a 1. If it helps to distribute the 3, you can. It'd be like 3x plus 15. Again, biggest exponent's 1, so I know that's linear. So y equals x. 7, we have those absolute value bars. So absolute value bars tell me that it is an absolute value function. So its parent is y equals absolute value of x. Oh, this is probably the first time you've seen an e. So an e is kind of like pi. It represents a number like 2 point something that goes on forever. So this is really like a number raised to an x, even though e doesn't look like a number. So it is an exponential. And really, frequently exponentials do have an e. They're involved in like finance equations. So e and exponential, I always think about how those go together. And it really is ex, which exponential starts with an ex. So the parent function for that is any number raised to the x. All right, only a couple more. So 9, I see a fraction, but notice x is not on the bottom of the fraction, x is on the top of the fraction, and it's being raised to the 3rd power. So that tells me it is cubic. So my parent function is y equals x cubed. 10, I see that ln, so right away I know that's going to be logarithmic. So its parent function is y equals ln x. The reason I write L's as cursive when I write that is because if I write ln x like this, I kind of feel like the L looks like a 1. So that's why I prefer to write it in cursive, but both of those are fine. Number 11, I see 2 x's. So notice they're in parentheses that are attached, so we know that those could distribute. And if I do x times x, I get an x squared. So even though they aren't originally looking like an x squared, x times x is x squared, so that is a quadratic. Then its parent function is y equals x squared. And finally, number 12, ooh, I see that e to the x again. So e to the x tells me exponential. So its parent function is y equals b to the x. Okay, hopefully that is helpful. The practice should be pretty quick because we're just identifying different types of functions. So good luck and have fun.